Hi everyone, welcome to another practice problem walkthrough by physacademy.com. In this video, first, we start by converting a vector's length and direction to coordinates and a bit of vector calculation. Then we'll practice finding the average speed and velocity using these variables. Let's read the problem statement and analyze it together. An amusement park roller coaster starts out on a level track 5 meters long and then goes up a 25 meters incline at an angle of 30 degrees up from the horizontal. Finally, it goes down a 15 meters ramp with an incline of 40 degrees below the horizontal. Consider the entire trip to when the coaster has reached the final ramp's bottom. Assume it takes 1 minute to reach the end of the last ramp. What is the total distance traveled? What is its displacement from its starting point? What is the distance from the starting point? What is the average speed during the trip? What is the average velocity during the trip? Before answering the questions, let us, as accurately as possible, sketch the displacement vectors of each section of the track in a coordinate system. The first section of the motion is straight along the x-axis for 25 meters. The second section of the motion is 30 degrees in a counterclockwise direction for 25 meters. Remember, the counterclockwise direction in the context of basic physics courses means a positive angle. The third section of the motion is 40 degrees in a clockwise direction for 15 meters. Again, clockwise means a negative angle, so here we have a negative 40 degrees angle. In Part A, we are asked to calculate the total traveled distance. The total traveled distance is like a car's odometer, meaning it measures the distance you travel without considering the direction. In this case, we have a 50-meter traveled distance followed by a 25-meter and then a 15-meter motion, so in total, we traveled for 90 meters. In Part B, we are asked to find the displacement from its starting point to the final location. Displacement is a vector that goes straight from point A to B, and it doesn't consider the actual path we had to take. This is like drawing a straight line between two cities rather than taking into account the road maps. In this case, the first vector is 50 meters along the x-axis and 0 along the y-axis. The second vector's length is 25 meters, its x-component is a cosine of positive 30 degrees, and its y-component is a sine of positive 30 degrees. The third vector's length is 15 meters, its x-component is a cosine of negative 40 degrees, and its y-component is a sine of positive 30 degrees. So in total, the displacement vector is 83.1 meters along the x-axis and 2.86 meters along the y-axis. The total distance from the starting point and the final location is simply the length of the displacement vector from Part B, which is 83.2 meters. Speed is exactly the value on the speed meter of a car, and it doesn't take into account the direction of the motion. Therefore, to calculate the average speed, we divide the total travel distance by the total travel time, which is 1.5 meters per second in this case. Velocity considers the direction of motion, therefore, we divide the displacement vector by the total travel time to find the average velocity. In this case, the average velocity is 1.386 meters per second along the x-axis and 0.043 meters per second along the y-axis. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, please consider subscribing to our channel to support our work.